Hello students, Stride here again. Today we're going to be looking at notes for section 14.4 titled Colligative Properties of Solutions. Our objectives: we're going to describe colligative properties, identify 4 colligative properties of solutions, determine the boiling point elevation and freezing point depressions of a solution. This objective we will work mostly on in class to work with the calculations involving it. We'll review vocab. We have an ion, which is an atom that is electrically charged. Nice new vocab here we'll come along to as we go through the lesson here. Our main idea: colligative properties depend on the number of solute particles in a solution. Here's our definition for colligative properties: physical properties of solutions that are affected by the number of particles, but not by the identity of dissolved solute particles. Colligative means depending on the collection. Some of our colligative properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Ionic compounds, electrolytes, they dissociate in water to form a solution that conducts electricity. If we get many ions, we call that a strong electrolyte. If we only get a few ions, we call that a weak electrolyte. Molecular compounds. Most molecular compounds do not ionize when dissolved and do not conduct electricity, and so are not electrolytes. There are a few exceptions. So molecular compounds that do ionize are called electrolytes. Vapor pressure lowering. We had a non-volatile solution, little tendency to become a gas. Non-volatile solute, little pressure, little tendency to become a gas. To a solvent, lowers the solvent's vapor pressure. When the solute is present, a mixture of solvent and solute occupies the surface area and fewer particles enter the gaseous state. Greater the number of solute particles, the lower the vapor pressure. Vapor pressure lowering due to the number of solute particles in a solution and is a colligative property of solutions. So if we have illustrated here, a closed beaker, you've got water molecules coming out into the vapor state, and you got some in the vapor state going back. And as it's a closed container, this will reach an equilibrium. As much comes out as goes in. But if we add a solute to it, in this case sucrose, that causes the number of particles moving out and in to be smaller, less vapor up here, less particles up here, lower vapor pressure. So the extra solute down here keeps more water in the liquid phase, less water in the vapor phase. So if it lowers the vapor pressure, boiling point's also affected. More heat is needed to supply additional kinetic energy to raise the vapor pressure to atmospheric pressure. Definition was the boiling point is when vapor pressure equals atmospheric pressure. Temperature difference between the solution's boiling point and a pure solvent's boiling point is called the boiling point elevation. Here's a little formula. We'll be doing some examples in class on a lot of calculations with that equation. Go in here, we get the delta T, boiling point elevation, K, molar boiling elevation constant, and M is the molality, little m. And each substance has a K given for it. Here we got water, benzene, carbon tetrachloride, ethanol, and chloroform. There's some various solutes that in there, Kb. Freezing point depression. At a solvent's freezing point temperature, particles no longer have sufficient kinetic energy to overcome interparticle attractive forces, so they stay in the solid phase. And the freezing point of a solution always lower than that of the pure solvent. Illustrated here, normal freezing point of water, freezing point of some solution of water. And we got a delta T. So, solute particles interfere with the attractive forces among solvent particles. Solution's freezing point depression is the difference in temperature between the freezing point and the freezing point of the pure solvent. And we have a very similar equation here that we looked at a little bit ago. Another equation we'll be using as we do some problems in class. And we have a Kf values here for same substances. Osmotic pressure, osmosis, diffusion of a solvent through a semi-permeable membrane. We got some semi-permeable membrane here, and we got water. And we got one side we got a low dilute solution, low concentration. Other side we got a high concentration or concentrated solution. And the water is trying to move through from low concentration to high concentration. It's trying to equalize the concentrations. So moving from here to here is going to raise the concentration over here and going to lower the concentration over here. Osmotic pressure, the amount of additional pressure caused by water molecules that moved into the concentrated solution. A couple quick review questions. Non-volatile solutes decrease the vapor pressure. Decreasing the vapor pressure also increases the boiling point. Colligative properties depend only on the number of particles in a solute. That takes care of this little lesson. That's all for now.